After data entry, data checking, data cleaning, and data querying, let's tackle the last step of our project, analyzing your hard-work data and visualizing results. It is tempting to click on the Data Functions tab on the word Next, then Data Analysis, and then on any of the available options for analysis. But you get something like this, disappointingly telling you that there is no automatic way of carrying out data analysis. You need to run a query, get the type of data, and then you need to connect to an external program to analyze your data. At best, if you click on either the network or GIS buttons, you get the following message that asks you to run a demo. Okay, let's try that and click yes. PCAce opens the query results form. Now all data analysis options are available through here, in this part of the form. Let's click on Net for Network and select Gephi as our program. PCAce opens a form where the user can select a variety of options for the network program Gephi. The input table that PCAce expects in input to create a network should have at least two columns, a node 1 and a node 2 field, here and here. In those two columns should be listed all the couple of nodes that are connected by an edge. You can also add a column containing an edge label, like this one, for the edge that connects to node 1 and node 2, and that will be displayed in the output. If you put any start and end date for any of the elements in the network, node 1, node 2, or the edge, PCAce will create a dynamic network where the elements will appear and disappear according to the time interval associated to them. You can select all the fields associated to those properties from this form. PCAce will recognize automatically certain names from the input table that are node 1 for the node 1, node 2 for the node 2, edge for the edge, and so on. So let's now run the procedure and let's visualize the Gephi graph. As you can see here, when you open a new file in Gephi, the layout of the graph is not so well organized. So you can choose a new layout from the Layout tab and then choose, for example, Fruchterman-Reingold. As you can see, the nodes now have been rearranged. We can zoom in or zoom out by using the scroll wheel on your mouse, or we can pan the tab by using the right click and then dragging around the image. You can choose to display labels on nodes by clicking on this T icon here, and you can also choose to display the edge labels by clicking on this other button here. You can choose to change the size of the labels by using the scroll bars, and the same thing for the edge thickness. Let's now click on the timeline. If we choose to shrink the temporal window right here to a few years, for example, and then we click on the play button there to run the model, we'll see that the nodes will appear and disappear, and so will do the edges, according to the dates that we have set in our input table. So the model shows how actors come and go in time, and PCAce has done all that automatically for you. Let's take a look now at the GIS option and run the demo now. Let's click on the GIS button right here, and then let's select Google Earth Pro. Like for Gephi, PCAce opens a form where the user can set various parameters that will affect the visual impact on the map that Google Earth Pro will display. Basically, there are three different parameters that a user can select in Google Earth Pro: icon, name, and description. If you're happy with the default values set by PCAce, you can close the form and display the map. So let's try now the default values and close the form. Let's open the file now, and here's the map. You can click on any pin to display the information contained in the description field, and notice up here how PCAce has passed a date field to Google Earth Pro, right there in this timeline. If you move the time bar back and forth, you will see different lynching events popping in and out of time. And PCAce also here has prepared the data required by Google Earth Pro automatically for you. Don't forget to watch the different videos on data analysis and visualization and on data querying.